Where can we use potential energy in energy conservation problems? Imagine a roller coaster at the top of a hill, full of energy ready to be transformed into motion. That stored energy is a perfect example of potential energy. It plays a big role in many energy conservation problems, helping us save and use energy wisely. Potential energy is energy stored in an object because of its position or shape. There are two main types relevant to energy conservation: gravitational potential energy and elastic potential energy. Gravitational potential energy is stored when an object is lifted to a height, like water in a dam or a raised weight. Elastic potential energy is stored when objects like springs or rubber bands are stretched or compressed. In hydroelectric power plants, water stored high in dams holds gravitational potential energy. When the water is released, it flows down and turns turbines, generating electricity. This process shows how stored potential energy can be converted into electrical energy efficiently, helping us produce clean power without wasting energy. Mechanical systems also use potential energy. Think of a stretched bow or a compressed spring. When released, that stored elastic energy turns into motion, moving arrows or bouncing back to their original shape. This principle is used in clocks, vehicle suspensions, and even toys. Recognizing these energy transformations helps engineers design systems that minimize energy loss and work better. Energy storage devices like batteries and capacitors also relying on potential energy. Batteries store chemical energy that can be converted into electrical energy when needed. Proper management of this stored energy ensures we use it effectively, reducing waste. Thermal energy systems, such as heat pumps, use the concept of potential energy indirectly. They transfer heat from cooler to warmer areas, conserving energy by reducing the need for direct electrical heating. This process depends on the energy stored in the form of thermal energy, which is related to molecular motion and position. Renewable energy systems also depend on potential energy. Solar panels convert sunlight into electrical energy, which can be stored in batteries for later use. Managing this stored energy helps reduce reliance on continuous power generation, saving energy overall. In everyday life, potential energy concepts guide improvements in insulation and energy-efficient appliances. For example, water stored in a tank at a height can be used for heating or other purposes without extra energy input, helping conserve energy. By understanding and applying the principle that energy cannot be created or destroyed but only transformed, we can design systems that store energy effectively and convert it with minimal losses. This is especially important in thermodynamics and heat transfer, where controlling energy flow leads to better energy use and less waste. So, potential energy finds its way into many energy conservation problems, from hydroelectric dams and mechanical springs to batteries and thermal systems. Using this stored energy wisely helps us manage resources better and move toward a more sustainable future.